All right, review of the atom. Good stuff. Stuff you've done before. Stuff we're not going to spend a lot of time on, so I'm going to blast through this pretty quickly. Looking at the parts of the atom, I know you know this. The positively charged particle would be the proton, the negatively charged particle is the electron, and the neutral particle is the neutron. The number of protons equals the atomic number. Protons plus neutrons equals the atomic mass. Looking at where these particles are located, protons and neutrons are in the nucleus of the atom, whereas the electrons here are going to orbit the nucleus. Notice that the electrons are much smaller than the protons and neutrons. Atomic number will never change, but the atomic mass can change, meaning the number of protons is permanent. You cannot change the number of protons in an atom. You can change neutrons, you can change electrons, not protons. When we vary the number of neutrons, we end up with isotopes. So the number of neutrons is different, but protons and electrons remain the same. So looking at the example of carbon and its isotopes, notice that the number of protons remains the same. You cannot change the number of protons. Protons equal electrons. Positives and negatives equal each other. So the carbon atom is neutral, no charge. But we have changed the number of neutrons. So you've got 6 plus 6, protons plus neutrons, equals 12, carbon 12. 6 plus 7 gives us carbon 13. 6 plus 8 gives us carbon 14. So the 12, 13, and 14 are referring to the mass numbers that are changing as a result of the different numbers of neutrons. Protons are constant. Atoms are always looking to become stable, meaning they want their outer energy level full of electrons. And the solution to becoming stable is to bond with other atoms. Most of the time we're dealing with atoms that are looking for 8 electrons. The exception for our purposes will be hydrogen. Hydrogen is always looking for 2. 2 equals full for hydrogen. Everyone else that we'll deal with will need 8. 8 will be the magic number for carbon, nitrogen, oxygen, all the others. All of the members of the first column here have 1 valence electron, and valence equals outer energy level. So I'll write that down. Valence equals outer energy level. All of these guys need or have 7 electrons, and they need just 1 more to be full. So we'll look at an example that includes sodium and chlorine. Both of these atoms are not stable. They want to be stable, and so they will bond. So you've got sodium with its 1 valence electron right here. This guy right there. Only 1. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7. So chlorine has 7, needs 1 to be stable. Sodium has 1 and would need 7 to be stable. It's a lot easier for sodium to give up its electron than to find 7 more. And that's exactly what sodium will do. It's going to ditch this electron, and that whole energy level will be gone, leaving the next energy level, which is already full. 1, 2, 3, 4, 5, 6, 7, 8. So sodium would be happy, would be stable. Chlorine would gain that electron, so it's 7 plus the 1 from sodium gives it 8, makes it stable. When one atom loses an electron and the other one gains an electron, we end up with ions. Ions are charged atoms. In this case, sodium lost an electron, so it now has a net positive charge, more protons than electrons. Chlorine gains an electron, so now it has more electrons than protons, and now has a negative charge. Stable and neutral are not the same thing. Okay, stable means energy levels full. Neutral means protons equal electrons. Not the same thing. Atoms that are seeking stability are oftentimes not going to end up neutral because they're gaining and losing electrons. Right? When this happens, we end up with ionic bonds. So here's my sodium ion, Na+, Cl-, opposites attract, and that is our ionic bond. So ionic bonds form between oppositely charged ions. And ionic bonds result in compounds like NaCl, which you know as regular old salt. When atoms share electrons, covalent bonds are formed, which result in molecules. Atoms that are covalently bonded make molecules. And so this image is from your textbook, looking at the different models of showing how molecules are built. But we'll look more closely at covalent bonding. A single bond means that one pair of electrons is being shared, whereas a double bond means two pairs. So right here you've got your one pair, your two pairs. A single bond, you've got just the one pair. So molecular oxygen, my last example, is considered diatomic. So molecular obviously implies a molecule. Molecular oxygen is what you know as O2. This is what you're breathing in right now. Just regular old O is just the atom oxygen. Molecular oxygen is two oxygen atoms covalently bonded to each other. So I'm only going to give the example of covalent bonding between two oxygen atoms, and we're going to save nonpolar and polar and types of covalent bonds for another day. So let's just look at two oxygen atoms. Oxygen, if you were to use your periodic table, has 6 valence electrons. So let's say here's a nucleus, and you've got 1, 2, 3, 4, 5, 6 valence electrons. We'll do it again. 1, 2, 3, 4, 5, 6. So neither one of these oxygen atoms is stable because oxygen wants 8 and currently only has 6. So the solution is to share electrons. So oxygen can share one pair and actually another pair with another atom of oxygen. Remember, these are both oxygen atoms. So now you're going to have 1, 2, 3, 4, 5, 6, 7, 8. This guy's happy. 1, 2, 3, 4, 5, 6, sharing 7, 8. Now this guy's happy. So both atoms have achieved stability by covalently bonding or sharing electrons. And you would write this as O2. And we say this is diatomic right here because it's two of the same atoms covalently bonded. Like H2, 2 hydrogen atoms covalently bonded. O2, you could do the same thing with nitrogen. You can have N2, bromine, Br2, 2 of the same atoms covalently bonded. All right, so be aware that ionic bonding is a transfer of electrons or results from a transfer of electrons versus covalent, which is sharing. We will get into the different types of covalent bonding on another day, but this is something that you should already know You have done bonding in the past.